We're going to move through this lesson very quickly, but that's not to mean that this material will be absorbed very quickly. You're going to have to pause quite a bit and try to really think about these concepts. But I will try to make this movie as short as possible and move very quickly. So hit the spacebar button quite a bit if you don't follow anything. So start with this, pause and try these derivatives. Okay, so you should have recognized that there is a function inside of another function. There's a composition of functions here. And when you have a situation like that, that calls for the chain rule. And so what the chain rule says is you take the derivative of the outside function and you multiply it times the derivative of the inside function. And so that product of those two functions, those two derivatives, we usually simplify like this. Over here, it's a little easier to see the composition of functions. We've got this quadratic function inside of this sine function. And so we have to take the derivative of the outside function times the derivative of the inside function and simplify it like this. Okay, so for a more formal look at the chain rule, once again, if you have a derivative of a composition of functions, it's the product of two derivatives. We're going to use this as a staging ground to understand how to use the u-substitution to find the integral. Once again, if I have the derivative of this, it looks like this. I didn't simplify it here, but I just looked at the derivative of the outside times the derivative of the inside. Because now, if we want to do the reverse process, what I need to have these two pieces together so that I can go back and create the original function. Alright, so I have the sine of 3x squared plus 4 plus c. Alright, so sometimes when a derivative, an integral like this is given, and we see the results, a lot of people will say, well, what happened to this 6x? It just sort of disappeared. Why did it disappear? The reality is both of these functions disappeared. They combined to make this function. It's sort of like a recipe. If you have this ingredient and this ingredient and you integrate it, then you create this new product right here, this new thing. All right. So it's a formula book where you have to have each of the correct pieces in place. If you have all the correct pieces in line here, then you can create this function here, the antiderivative. Okay, so that's really sort of how we're going to approach these. Let's not think about, well, see where this went, I didn't see where this went. They actually combined together. Okay, so and we should see that from the chain rule. All right, the derivative of the outside times the derivative of the inside. Need both of those pieces there. Okay, so I'm going to walk through this example problem. I have a function inside of a function I need to integrate. So what I need to do is I need to identify what the inside function is. And I'm going to call that u. So this inside function is 1 minus 2x. And if I find the derivative of both sides, the derivative of u is du, the derivative of 1 minus 2x is just negative 2 dx. Okay, so now if I take a look at my original function, I have this, but I'm missing, and so I can change this into u. That's no problem. I can substitute u in here, but I cannot substitute du in here because what I really need is I'm missing this negative 2. If I had a negative 2 in there, then I can change this piece into du. So what I do is I introduce it. I go ahead and insert a negative 2 in here. I'm allowed to do that as long as I counteract it with a minus 1/2 in the front, because those two products cancel out to make 1. So if I add a negative 2 here, I have to put a negative 1/2 out in front, and then I'm set. I can change this into u squared, and then I can change this, the negative 2 dx, into u. I'm sorry, du. So what I've done is I've transformed this original function here, an integral that deals with x, into a more simple function, a more simple integral with u's. So what I am going to challenge you to do is I want you to find the integral of this function. Go ahead and press pause. Okay, hopefully you just use the power rule. So I take this power, I add 1 to it, and then I have to divide by it. So it's u to the third, so 1/3 u to the third plus c. Let's not forget this negative half out front. So this negative half multiplies this u to the third. Technically, it also multiplies this plus c. But I know that minus 1/2 times some constant is just a constant. So that's why we usually don't bother adjusting this plus c. We just know it's a constant anyway. So it'll just be some other different constant, but still a constant. So I still simplified this to negative 1/6 u to the third. Now I don't stop here because the problem wasn't written for u, it was written for x. So what I should do is resubstitute 1 minus 2x in for u, and then that's my final answer. Okay, so this is the result of this integration. Let's try this problem. Perhaps you might press pause here and see if you can do this on your own. Otherwise, I'll go ahead and start talking about what functions on the outside. Looks like there's 3 functions. There's this 6x, there's this cosine, and then there's this inside function. So let's always call u the innermost function. So we're going to make u equal to 3x squared plus 4. So if I take the derivative of both sides, u becomes du, and plus 4 disappears, so I get 3x squared. That just becomes 6x dx. So I should be poised to substitute these u's and du's into the original equation here. So it looks like I can go ahead and change this into a u, and in fact we have the pieces for du as well. There is a 6x and a dx, and so what I've done here is I've just taken the same problem and I rewrote it. I just moved the 6x over next to the dx. Right? Everything else is the same. This is exactly the same. I just changed the order so that you can see that this equals du. Okay, so I have cosine of u du. So I should write the integral of cosine u du. The integral of cosine is sine. So this is going to be sine u plus c. You substitute back in for u, and so this is our final answer. Okay, please try this on your own. Press pause. Alright, what did you find as u? Well, the u is the innermost function. So we call u equal to 1 plus x squared. So the derivative of both sides gives us this result. We should see that the 2x and the dx combine to make du, right? 2x and dx combine to make du. So then I can change this part into u. Okay? So now I have square root of u du. So then here we have, we've changed this into the integral of the square root of u with respect to u. To do this, we should probably change u to the 1/2 power, so you can use the power rule. Press pause and see if you can finish this problem without any help. Okay, so you should have found the antiderivative is 2/3 u to the 3/2 power plus c. We substitute u back in, and so this is our final answer here. Alright, so next problem. Integrate this. Go ahead and try it on your own. Alright, so again, we sort of have like 3 functions here. This one up here, we've got this big outer function and this inner function. U is going to be the innermost function, so u is going to be 2x squared plus 1. We find the derivative of both sides. And now it looks like we've got the right pieces of the puzzle to start moving around, but maybe what I can do is I can try to show you that a little bit more clearly. What I'm going to do is I'm going to move this 4x, instead of being on top, I'm just going to move it off to the side. Alright, so what happens when I move that 4x off to the side? I get 1 here and 4x over here. Alright, it's sort of like sometimes you see like 1/2 times the square root of 3, and we say we don't usually like to write it like that, so we usually write it as root 3 over 2. Okay, so we're sort of using the same idea. I can just slide this root 3 up on the top. Well, now I've slid it back down to the side. I've slid this down back out to the side, and so I have this times this, and hopefully you can see that this is du. Right? 4x dx is du. So I can change this into du, and then over here I've got 1 over root, and then this is u. So I can change this whole integral into 1 over root u du. And then if I use my negative exponents rules, then I can actually change this into this. So my final So what I've done is I've transformed the original integral into something a lot more familiar. So see if you can finish it from here. Okay, so the antiderivative is going to be 2u to the 1/2 power plus c. If I substitute and then change this back into a square root, I should get something like this. Alright, we're going to do one more. Alright, see if you can try this on your own. Okay, what is u? Well, we got 3 functions. This one down here, this bigger one, and this inside one. So u is going to be the inside one. So u is going to be root x. So du is going to be this. Alright, now I can rewrite that. I can rewrite this sort of mess to look something like this. Why would I do that? So that I can start matching what I've got over here with the original problem. So if I see, what I can do is sort of rearrange this so that the pieces of the puzzle look a little bit more familiar. I've slid this sine x, root x out, and then I've got 1 over root x dx over here. So this and this are exactly the same. So now, hopefully, I can see that what I really want is I want this, and I've nearly got it here. The only thing I'm missing is a 2. I'm missing a 2 here. I can go ahead and insert that 2 though. So that's what I've done. I said I want a 2 here, but I have to counterbalance that by putting a 2 out in front. Why 2? Well, because this is really a 1/2. It's not. It's a 2 down the denominator, which is really a 1/2. So the reciprocal of 1/2 is 2. So if I multiply 2 times 1/2, they cancel out, right, and make a 1. So so now hopefully I can see that these match. All right. So now I have a match. This whole chunk just changes into du, and then this becomes sine of u. Okay, so 2 sine of u du, and then I find the antiderivative plus c, don't forget the plus c, and then I substitute back in, and so I get negative 2 cosine root x plus c. Alright, so that's using the u-substitution for slightly more complicated problems where it might be difficult to see what the inside function and the outside function is. And if this is new. This is part of the new syllabus that IB started last year. So these are problems that you can start seeing on the exams since 2014. So you should be expecting that they're going to emphasize these problems on our exam. Since it's new, they're going to want to get it started. Anyway, hopefully you understood.